use. Okay. Hello everyone. Welcome to Math 12. We have online course on pre-calc, algebra and trigonometry this term because of the COVID-19. My name is Kongxia Lu, and I'm in the Department of Physics, Chemistry, and Mathematics at Alabama A&M University. So this is my name. Just interrupt me anytime if you have any questions, any concerns, or any other issues. Okay, so this is my information. My office is located in Engineering Building at room 257. For convenience, I also give you my cell number instead of the office number because we'll do it online. So you can reach me anytime. I actually got a call this morning from my other class asking about the
Can you
information
repeat
about
where
the
your
online
office
course.
is again?
Office is engineering building at room 257. Can you see it?
Yes, I see it.
Yeah, you'll probably not to go to my office for a lot of times in this semester because of the virus. But just provide that information to you in case you need it for some special reasons. Okay, my cell number is 256-468-1557, and my email address is this. So you can contact me in any means, in addition to the emails or Blackboard. I have built a Blackboard discussion board in Blackboard. If you check it, so you can also leave a message in there. I can answer questions. You can also discuss any issues with this course with you classmates in the board. Okay, just check everything in Blackboard. I'm going to put a lot of information there for you to view to help you with the course. Okay, can I go to the next page?
Yes.
All right. Okay, so this is the course information. The textbook we're using is by Larson, Algebra and Trigonometry, 9th edition. The good news is, as I said last time, we don't need to buy the textbook because once you buy the Xcode with a discount price, as we are still working on it, once we get it fixed, then I'll tell you when to buy it. Hopefully you'll get a big discount for the price of the Xcode, and you can access all the materials in Web of Science and do the assignments. And the ebook is included. Okay, you cannot hear, Kevin? I think you got the same problem last time. I guess you got maybe you have problem with internet. So try to improve internet a little bit. Okay, this is essential. All right. So let me just respond. So please. Okay. What log out and log in again and see if that works a little better. Okay. You know, I don't want you to put this on black. Yes, I already put this in Blackboard. I don't want people lose the information because of the internet problem. Okay, so when you buy the Xcode from WebScience or Cengage and create account, then you can access all the resources in WebScience to do the assignments and to use all the resources there, including the ebook. Okay, they also have all the sections, videos for each section, and then they have some other information on other resources that you can use. You can take a look at it. Although you don't have the access code right now, you can still access WebAssign now because I already integrated Blackboard with WebAssign, and you can access with the grace period, which is about 3 weeks, I think 2 to 3 weeks. So you don't need the access code to access the WebAssign resources right now. But after the grace period, you will need to buy it. Okay. But if you want to see, how that looks like in WebAssign, you can try it. What you do is log into Blackboard, and then click on the tools. I explained that in email, but let me just tell you again. Click on the tools, and then you're going to see WebAssign on the top left. The first icon or link, click on it, and it will direct you to WebAssign, and then you can explore what is in there. So that's the way to do it. So why don't you try it if you didn't use it before? Any other questions so far? Okay.
No, sir.
All right. Okay. So as I say, the students will buy access code from WebAssign Syncage with a discount that will tell you when to buy it. Okay. So just wait a few more days for us to fix the discount. We have a grant to support students on that, and it's pending for final approval by the university. Once it's approved, then hopefully you get a big discount. And we are also negotiated with the Syncage to have a little more discount. So at the end, you should have a good price for the access code. Okay. And then students log in WebAssign through Blackboard. I just said that. Also read emails or announcements in Blackboard explain the way to log in WebAssign through Blackboard in details there. Also, the soft package of WebAssign includes textbook, online assignments, and study tools. Okay, and videos and other things. The course grade is based on the points made in assignments and the class activities. I think I explained last time. I also put the syllabus in the information folder in Blackboard if you check it. So please look at the syllabus clearly and see how how this information is in there. Students can interact with instructor in WebAssign as well as Blackboard, the panel session. Okay, so I already created a discussion board. If you click on discussions in Blackboard on the menu, just check everything on the Blackboard menu. I have put a bunch of things there, and I will continue to do that. So you can leave a message in Blackboard panel session or discussion board. Also, once you do WebAssign problems in assignments, for each question you work on, you can actually interact with me or send a message to me right beside the question. There's an icon saying, asking your instructor or your teacher, something like this. And you can just put the question there and send to me. I'll respond it. Okay. So any questions at this point? Anything not very clear? So again, the first thing we need to fix is to make sure everybody is comfortable with this online format of delivery of course, and nobody has any problem to join our online session. Okay, this is the bottom line. We have to do it perfectly. Okay. Okay, next page. So this is the course outline, what we're going to cover. We're going to cover 3 chapters. Okay, it looks like we don't have much, but actually there's a lot of information for these chapters. And all of them are very basic and essential, but I think many students are not very solid on those basic skills and the concepts. Okay, so we're going to cover chapter P, that's the prerequisites, and then equations in chapter 1, inequalities and mathematical modeling, chapter 2, functions and the graphs. All of these are the foundation of mathematics. And they are not extremely difficult, but some of them are very tricky. So you have to pay special attention to that. If you don't learn them, you will not know how to do that. Okay, so you do need to study. Okay, any questions about this introduction so far? You can ask me questions, regarding this course anytime. Just interrupt me, or if you have any question, any problem hearing me clearly, or you cannot see the board clearly. Okay. If you don't have any more questions, I'm going to go to the actual materials of the course to start. We have good attendance today. All right. Let me just oh, we have 20 now. Okay. To share more things to you. Okay. So I'm going to get it from my folder. Okay. Okay, so that's the first section of the chapter P. Just wait a few seconds for the download or uploading of the file. All right, I think it's there. So let's just start chapter P. All right. Okay. Okay, I think you can see it. Can you? Is it good?
Yes, sir.
Okay, so chapter P, prerequisites. So the first section of chapter P is review of real numbers and their properties. Okay, so everybody knows what the real numbers are, but you make sure you know the difference between different terms and definition of different sets. You can divide real numbers in different categories. For example, what's the question? Any questions? So let's look at one example. It says determine which numbers in the set are A, natural numbers, B, whole numbers, C, integers, D, rational numbers, and E, irrational numbers. This set includes 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Negative 13, negative square root 5, negative 1, negative 1/3, 0, 5/8, square root 2, pi, and 7. So there are different numbers in different categories. And we need to find which numbers in this set are natural numbers. Okay, there is only one natural number in this set. By definition, natural number is a positive integer. So it has to be positive. It cannot be 0. And it has to be integer. So the only number is 7. All the numbers are either negative or fractions or radicals, or pi is an irrational number. That's not integer, obviously. So that's A. Part B. What are the whole numbers? The whole numbers are the natural numbers plus 0. So I just put the 0 in. So we got two whole numbers, 0 and 7. All right. Integers. Okay, so then integers is basically negative numbers including. All right. So we put the negative 13 and negative 1 in addition to 0 and 7. So there are 4 integers. Okay. So integers include both positive and negative numbers. And the next thing is called rational numbers. Okay, so obviously we just add more numbers in. So rational numbers, we know fractions are rational numbers. So we got the 2 fractions to add in, negative 1/3 and the 5/8. So all of these are rational numbers. Okay. So we just enlarge the set, gradually, step by step. And out of the integers, negative 13, negative 1, 0, 7, they are also part of the rational numbers. Okay. It's not just the fractions, but also include integers. Okay, so the last thing is called irrational numbers. Those are radicals and pi. Okay, so we got 3 irrational numbers, negative square root of 5, and square root of 2, and a pi. So these are numbers that you cannot write in fractions. Okay, so this is the categorized, sets in real numbers. We divide real numbers in different categories. Any questions? Okay, any questions? So you can hear me clearly, can you?
Yes, sir.
Yes, sir.
Is the board
Yeah.
clear? Okay, all right. So that's the real number. Okay, so one of the important properties of real numbers is you can order real numbers. That means you can compare any two real numbers to see which one is bigger and which one is smaller. So for example, we can place the appropriate symbol for the following pairs of numbers. So we have four pairs of numbers, and we need to compare which one is larger, which one is smaller in each case. So in the problem A, we got 1 negative 5. So which one is bigger? 1 is bigger. Okay, remember we are putting in a negative, then it will be smaller, right? So keep in mind the positive numbers are always greater than any negative number. Okay, so we put a greater than sign. Okay, so that's the symbol, greater. Okay, 1 greater than negative 5. So that's how you write it. In problem B, 3/2 and 7. Okay, 3/2 is if you convert into decimal, if you want, is 1.5. So that's obviously less than 7. So we put the symbol less in part B.
So he
that's
went
the
right
symbol.
past it, man.
What's the question? Okay. So that's the part B. Part C, we got two negative numbers, and they are both fractions. So that makes it a little more complicated. So the first thing is to compare the magnitude. So okay, just forget about the sign. 2/3 and 3/4. Which one do you think is larger in magnitude?
1.
And 2/3. We are talking about 2/3 and 3/4. If you think about the magnitude of those two numbers, which one is larger?
3/4.
3/4. Yes, you can try to convert that into decimals, 2/3 is about 0.67, and
67
3/4
and is 75%.
yeah. So obviously 3/4 is actually greater than 2/3 in
But it's
magnitude.
negative.
Yes, then you put the negatives on both, then you have to reverse the inequality. So you get negative 2/3 greater than negative 3/4, right?
Yeah.
Okay,
So
so that's yeah. So when you compare negative numbers, you have to reverse the order from the magnitude comparison. Okay, you get more negatives, then that means it's actually smaller. If you think, put the numbers in the vertical axis, then that means the deeper it is, the smaller it is, right? So that's
Right.
negative. Okay, the last question is obviously we got negative 3.5, and then one obviously, all the negative numbers are less than positive numbers, so that's easy. Any questions for this problem or example?
no, sir.
Good. Okay, so these are pretty easy. Let's see. I need to go to the next page. Okay, so let's talk about ordinary real numbers a little more. This time, we're going to introduce some notations for the order. As just did, we put some negative sign, but you can also have negative less than or equal to. Okay, so in this example, we want to describe the subset of real numbers that the inequality represents. So each of these two questions describe a subset of real numbers. So for example, in part A, we have x less than or equal to 2. That means all the numbers represented by x are less than or equal to 2, right? So, you put the x there, that means, you have to include all the numbers that are less than or equal to 2. And that can be represented by the inequality, x less than or equal to 2, or the word, all real numbers less than or equal to 2, or in graphical representation by the horizontal line. Okay, so you can see the horizontal line, that's the x axis, pointing to the right direction, and we mark 0 at the origin on the number line, 2 on the right. Okay, so all the numbers, all real numbers less than or equal to 2, so that's on the left side of 2. So we use a thicker horizontal line to represent all those numbers on the left side of 2. And we put the bracket opening to the left. I mean, the number 2 is included in this set. All right, clear? Does it make any sense? So, you just look at the number 9, and the thick part is the graphical representation of the set. It includes all the numbers on the left of 2, including 2 itself. Okay, so you might not be very familiar with this decision, but this is the one thing that you have to get used to in math. And we use bracket at 2, opening to the left, to include 2 is included in this set. So that's part A. Part B, x greater than or equal to -2 and less than 3. That's how you read it. So that means all the real numbers between -2 and 3, greater than or equal to -2 and less than 3. So that's all the numbers between -2 and 3, with -2 included, because we got an equal sign on the left and no equal sign on the right at 3. So 3 is not included in this set. So in the graphical representation, okay, you just draw the number 9 again and mark -2 and 3 on the 9. And then you just put a thick line between -2 and 3. But the difference is at the -2, we use a bracket opening to the right, and at 3, we use a parenthesis opening to the left. To mean 3 is not included. There's no equal sign in the inequality if you look at the original problem. So we use a parenthesis, but the -2 is included in the set. So we use a bracket. So you see the difference in the notation between these two cases, right? Does it make any sense to you? Any questions?
No, sir.
No, sir.
Okay, it's good?
No. Yes.
No? Oh, okay, yeah. Just make sure you know these notations, because from time to time you can use it later. Okay, so that's the graphical representation. Okay, so let's just talk about this topic a little more. You can use different to describe the same mathematical set. For example, how do we give a verbal description of the interval from -2 to 5? So that's another notation for the same kind of set. Okay, so again, you see the bracket on the left and the parentheses on the right. Just like the graphical representation, we can also use to write in intervals. So on the left we got -2, and on the right we get 5. So that means all the numbers between -2 and 5, including -2, but not 5. Okay, so this is very similar to the graphical representation in the previous page, right? So we can say that includes all your numbers between -2 and 5, including -2, but not 5, isn't it? Just like the same thing in the, in the part B of the previous example here. Okay, we got the bracket on the left and parentheses on the right. We can do that without the number 9, and instead we write the two numbers in unit using this same notation, and they mean the same thing. Okay, so that gives us the into notation. So that's another notation. So you can just see all of these things, probably later. Okay. So let's look at another example. The inequality C less than equal to 2 can represent the statement C is at most 2. Okay. When we say C is less than equal to 2, that means all the numbers less than or equal to 2. In other words, you can say C is at most 2. So these are two different phrasing for the same fact. Okay. And another example is the inequality -3 less than x less than equal to 5. So by the way, how do you read this inequality? You just read it from left to right. Okay. So this inequality is -3 less than x less than equal to 5. Or you can say x greater than -3 and less than equal to 5. So you can read it from the middle also. All right. So that can represent the statement all x in the interval from -3 to 5. Okay, so he got the same problem again. Okay, so, I think he got a little problem with the internet connection. I don't know what to do. So for this example, we just convert the inequality representation to the interval representation. Okay, so put the parentheses on the left at -3 to mean -3 is not included in the set, and put the bracket at 5 on the right to mean 5 is included in the set, as we it shows in the inequality itself, right? So these are two different representations. You can, convert it from one to the other. Okay. So I don't know how to say it. Okay. So please improve internet quality or connection. Okay. That I think it's not. It's pretty usual that you get disconnected sometimes, because it does happen even in my case, on my side. So the only advice I can give him is just to get a better internet connection. Okay. So you need to make sure it works well. Any questions so far about ordering real numbers? We have different notations. Basically, I just introduced those notations a little bit. Can I go to the next page?
Yes, sir.
Yes.
Yeah.
All right. Okay, great. Okay, so let's talk about another thing. It's said absolute value and the distance. Okay, so let's talk about the absolute value now. Everybody knows what absolute value of a number is. That's the magnitude, basically. If you say -2, the absolute value will be 2 because that's the magnitude. If you say +3, the absolute value of 3 is 3 itself because that's the magnitude, right? Okay. Okay, so here is a pretty tricky question or example. We need to evaluate the absolute value of x over x. By the way, the absolute value notation is the double bar sandwich the variable x. Okay, so that's the notation for absolute value of x. So we divide the absolute value of x by x itself. All right. Okay, so we need to evaluate this. What is equal to for two cases. Case A, when x is positive. So x greater than 0, that means x is positive. Okay. And B, x less than 0, that means x is negative. Okay, so how do we do that? So import A. If x is greater than 0 or positive, then the magnitude of x will be, or the absolute value of x is just x itself. Okay, so we got the absolute value of x over x equals x over x. So you cancel it, you get 1, isn't it? So that part is easy. For example, +2. The absolute value of +2 is just 2 itself. So the absolute value is equal to the x itself in this case, right? Does anybody agree with me?
So
Yes,
if
sir.
x,
Yes.
Any questions?
so x over x
Yeah,
equals 1.
you cancel the x, right? 2 divided by 2 is 1, isn't it? Okay. If there's any question, let's talk about the case when x is negative or less than 0. And here's the absolute value of x is equal to a negative x. How do you understand this? Okay, so let's talk about -3. When you take the absolute value of -3, what do you get? You get a +3, right?
Yeah, it changes
Yes.
to positive,
So you
right?
need to put the not. Yeah. You need to put a not negative in front of -3 to make it positive. Does it make sense? So the absolute value of -3 is equal to negative of -3, which is +3. So when you take the absolute value of a negative number, you change the sign.
To a positive.
In other words, to get a positive. Because x itself is negative. To get a positive, then you have to negative the negative number. So this time we got the absolute value of x over x equal to negative x over x. And if you cancel x, you get negative 1. So 3 over negative 3 is negative 1. Any questions for this one? I know some people got a little confused about this absolute values when it gets complicated, like this example. Is it clear now here?
Yes, sir.
Yeah, just think about it if you do have some doubts. All right. So can we go to the next page?
Yes, sir.
Mm-hmm.
All right, great. Okay. So let's talk about the distance now. Distance between 2 points on the real number 9. Okay. We use the notation D parentheses A B. Okay. So that means the distance between two numbers A and B on the number 9. So you can mark the two numbers A and B on the number 9, and you want to find how far these 2 points are. So it turns out that we can use absolute value to find the distance. That's one of the applications of absolute value. So you just subtract these two numbers and take the absolute value. So you can subtract B from A or from A to B. When you take the absolute value, they give you the same answer, okay? So it really doesn't matter which minus which. At the end, you're going to take the absolute value. So for example, how do you find the distance between negative 25 and 13? So you can write the D parentheses negative 25 and 13 equal to negative 25 minus 13. So you subtract two numbers in this order, you're going to get a negative 38, right? So make sure you know how to subtract negative numbers. So you get more negative, basically, from negative 25. But then you take the absolute value, it becomes positive, so it's 38. So the distance between these 2 points on the real number 9 is 38. Or in another way, you can flip it to write it D parentheses 13 and negative 25. You can subtract 13 minus negative 25, okay, in this way. And then you got two negatives inside absolute value. You got, that becomes plus, so you got 13 plus 25, which is also 38. So this time, you take the absolute value, just get the same number, 38. So it really doesn't matter which minus which. At the end, you can take the absolute value. Any questions? Can we go to the next page?
Yes.
Are you with me? Okay. Yes, I want to make sure everybody is good. Okay, because we got very good enrollment today. I'm pretty happy with that. I want everybody follows me well. Okay. All right. So let's talk about the algebraic expressions. Okay. So this is a different thing now. What do you mean by algebraic expressions? We mean both the numbers and the variables. Okay. When you have the numbers like 1, 2, 3, 4, and variables x, y, z, you mix them together, then you call that algebraic expressions. You can mix them in different ways. You can add them, you can subtract them, you can multiply them, you can divide them in any way you want. Okay, just put all the numbers and the variables in one basket and just mix them together. Okay, by using the arithmetics. Okay. So for example, identity. Okay, I'm sorry. This should be identify. Okay, identify and identify the. Okay, the question is actually identify the terms and the coefficients of this expression. Okay, so negative 2x plus 4. That's called the algebraic expression because we got the numbers and the variables mixed together. Okay, so we need to identify the terms and the coefficients in this expression. Okay, so these are some terminology. The term means how many parts do you have to add or subtract. Okay, it means adding or subtract. So we got two parts, negative 2x and 4, so we call them terms. So there are two terms in this expression. And the coefficients are the numbers. Okay, the numbers are called the coefficients. Okay, so we got two coefficients, negative 2 and 4. For specifically, negative 2 is the coefficient for the first term, and 4 is the coefficient for the second term. So in this notation or this terminology, is good. Pretty easy, isn't it? Okay, next page. Basic rules of algebra. Okay, so this when we do addition and subtraction, multiplication and division of expressions we just talked about, algebraic expressions. How do you add them? How do you subtract them? How do you multiply them? How do you divide them? Okay, so there are some basic rules. For example, how do you rewrite a fraction x over 5 in equivalent form? You can multiply both the top and bottom by the same number, 3, for example. Then you get 3x on the top and 3 times 5, which is 15 at the bottom, isn't it? Okay, so this one property of fractions. You can multiply or divide the same number at the bottom and on the top, and then those two fractions are equivalent. They are the same in value. Okay. In the next example, we want to divide fractions. Okay, so we need to know the basic rules how to divide fractions. So when you divide two fractions, you need to flip the second fraction, or multiply the what is called you need to flip it. Okay, so for example, we got the 7 over x divided by 3 over 2. So you just flip 3 over 2, you get 2/3. So that gives 7x times 2 over 3. So make sure you know how to multiply fractions. You multiply top by the top and the bottom by the bottom. You do not do the cross multiply. Okay, so make sure you know that. So then you got 14, 7 times 2 on the top and 3x at the bottom. So that's how you divide fractions. Any questions?
No.
Okay, we got the one more page in this section, but I don't think we're going to finish today. So I don't want to take too much time from you. So I'm going to leave the last page from to next class. That's about add fractions. I know a lot of people got the problem with it, so let's just leave it the next time. So any questions about anything today's class?
No, sir.
Okay, I guess we're good today. We got the good attendance today, and it looks like you are following pretty well in the lecture today. So I'm gonna stop here. It's already 1:50, and I'll try to put the video. We just recorded it in Blackboard. Okay, this will be a large file. Let's see if it works that way.
Will you be putting
but
the PowerPoint on there too?
I will put the PowerPoint always in Blackboard in the content format. But
Okay,
I will
thank you.
try to also put the video. I just recorded it in the same folder, but I don't know how if it works because this would be real large. I'll try to do it. Okay, so you're free to go. I'll see you on Friday. All right.
Have a good day.
Have a good day.